Hi, hello viewers. Alright, now we are going to be looking at this question. It's a Faraday electrolysis calculation, and the question says calculate the time it will take to deposit 1 mole of silver if the current is 6 ampere passed through a solution of silver thiazolonitrate, and we're also given that 1 Faraday is equal to 96,500 coulomb. That's a constant value. We know the Faraday's number is 96,500 coulomb. Now, let's simply spell out all the parameters given to us. In that question, we are asked to calculate for time, right? Question mark. We don't know the value for time, and we are also given the number of mole. We are told that the number of mole is 1 mole, right? So the n here is 1. And also we are told that the salt in this that is dissolving is silver nitrate, and we know silver is a divalent salt, right? So our C here, which is the valency of that particular metal, is equal to 1, and also our Faraday's number, which is F, is equal to 96,500 coulomb. I think that's all we have. We're also told that the current that passed through is 6 ampere. Alright, so these are all the parameters that are in that question. Now let's all solve. Recall that the formula for Faraday electrolysis calculation is number of mole, which is N, is equal to mass all over the molar mass, which is also equal to the current times the time all over what? The valency times Faraday's number. So this is the formula. But in this formula, we are going to be making use of just one. There are 3 formulas here, depending on what was given to us. Now, since we asked to find time, definitely we are going to make use of this formula because it has T in the time that we are looking for. And also, we are told number of mole, right? We are given number of mole, which is N. So definitely we won't use this particular formula. So the formula we are adopting from that is N equal to I times T all over C times F, where our N is the number of mole, which is 1, I is the current, T is the time which we are asked to find, and C is the valency of the particular metal, which is 1, and F is the Faraday's number. Alright, now let's quickly solve. Our N here is 1, which is equal to our I times our I is 6, right? The value of I is 6 ampere, times our time, which we are asked to find, equal all over 1, which is time, and then times 96,500. And let's simply do that. This will give us 1 over 1 equal to 6 times T gives us 6T all over 96,500. If we multiply that, this will give us 6T, right, equal to 96,500. So at the end of the day, our T is going to give us what? 96,500 divided by 6, right? 96,500 divided by 6, and let's quickly do that. 96,500 divided by 6 gives us our time there. Our whole answer will be equal to 16,083 seconds. 16,083 seconds. Alright, so that's the answer. The time to take for this particular metal, silver nitrate, to complete its electrolysis process around the cell is 16,083 seconds. You can convert that into minutes. Do that in the comment section, and bye for now. Have a nice day also.